Hello and welcome to Tomorrow's Trends, a show where we dive into the hot topics of technology and business today to see how they'll shape the future of tomorrow. Each episode, we try to have important guests on that have expertise in particular areas, and today is no exception. Joining me today is Scott Chapman, and to give you a little overview of who Scott is, he is an engineer that has worked for over 30 years and has a full spectrum of understanding and knowledge in the industrial automation space, doing things from being an electrical helper to being a senior nuclear INC automation programmer, designer, project manager, and engineer. He is really a jack of so many trades, and I'm excited to have him on here today to dive into a couple of topics. He can bend rigid conduit, he can pull cable, calibrate instrumentation, valves, and automate new processes and things like structured text. He specializes in a whole host of things, PLCs, DCSs, drives, pneumatics, on and on and on. He has a wealth of experience. But he's not just that. He's also a family man. He's been married for 22 years to a wife that is a very skilled photographer. They have 5 amazing children. He's the one person that I know that has one-upped me in the children count because I have 4. So thank you so much for joining me here today, Scott. And I look forward to digging into a few topics. How are you doing today?
Ira, I'm doing pretty good. And thank you for having me on. I think this will be my first podcast. You know, you saw a little bit about the first conference I did last month. And I'm excited to be here. My oldest daughter will get married next month, and so one of them will move out. I'll be on the same page as you for coming year home. And I've really mostly been in maintenance and construction work for most of my career. Just kind of fell into the engineering part.
Yeah.
But that background is why things like maintenance kind of are important to me.
Yeah, it seems like that's a common trait of a lot of engineers. You kind of just fall into it. You know, it's the knack, it's the whatever. It catches you by surprise. But the maintenance side of it, now that's interesting because a lot of times you get a lot of these different angles, and maintenance is a super important topic before every manufacturer, because if you're not maintaining your equipment, bad things happen, right? And when we look at maintenance, really, the things that come to my mind are predictive and preventative maintenance. And I know we'll explore some other things here in the future to kind of be a little bit more forward-looking, like we typically do on this podcast. But for the lay of the land, this may be common knowledge, but can we give a definition of what predictive versus preventative maintenance is, and maybe even just explain why maintenance is important?
No problem. So reactive, going one step backwards, reactive is fixing the things that are broken as they break. And I mentioned that first. That's where most companies spend way too much time, most of their time. So preventative maintenance, it's there to look at the run hours, look at a time schedule, change the oil in your car type of thing before it goes wrong. And that's where companies have been for years, but it's where I should say they try to be. They're so busy fighting and changing the broken stuff and the problems, they don't even keep up with their preventative maintenance schedule. And even the ones who do, you still have these other things that happen. You sprung a leak in your hydraulic line or your oil in your car or something, and you didn't get to the number of hours, you didn't make it to that schedule, but you still had a failure. So predictive maintenance, now we're gathering data. We get one problem is too much data and don't know how to use it. Another problem would be people not knowing how to look at the data properly. But the predictive maintenance is using that information and predicting when the failure will happen. So it hasn't happened yet. It may not happen for another year, but you can already tell the direction it's heading. So fix it before you get there. Plan for it. It's going to take us 2 hours to change this part or a whole week to fix this stuff. So you plan for that.
Got it. So So maybe just to restate what you said. So you added one there to the reactive, right? And I think that's an important one to add because let's face it, everybody has a maintenance plan, whether it's predictive, preventative, or whatever it may be. But then there's the reality of the situation, which is stuff's broken and I need to react to it right away. So,
Things down.
Exactly. So, if you think about your car, right, you can have the preventative maintenance. I think you mentioned the oil change, right? Yeah, every so many miles, you got to go change it, whether it's going bad or not, or you should go and change it. But like tire blows, you got to react to that. You got to take care of it right away. That's the reactive state. And then looking at the predictive, well, that can, you can use data, you can use information, and you can potentially predict the future to figure out maybe how things can work better when they need to happen or whatever they need to do. And you mentioned data, and you mentioned too much data potentially being one of the challenges here. So this is where one of the reasons I really wanted to talk to you, Scott, because yes, at the OT SCADACon, I know you dove into this topic, and I know you even went a step further and looking at the different types of maintenance things, but looking at predictive maintenance, can you maybe unpack that a little bit more? And like, what are some things you can do in that regard, or are there any avenues that can be a little bit more trending to help systems work better? Some examples in that area.
Well, rotating equipment has been kind of where it started even back in the 1940s, which is crazy when you think about today. People are still reacting all the time because of these unexpected breakdowns, when we actually had predictive maintenance from way back then. But in the rotating equipment, like I said, so your turbines, your motors, your big compressors, bread and butter of that, predictive maintenance line of work, the vibration and temperature. And those are, like I said, they tell you, hey, we're out of alignment. We have, there's a rod knocking or something. And then you get into Fourier series and harmonics and things. Vibration can tell you, from the compressor and the motor, you need to, put a shim of 0.03 thousandths of an inch in there. Because if you don't, it will be out of alignment. It will have a little extra vibration, which will over time tear it up. Now, sometimes you have a lot of time. So I've seen equipment where, this is what's wrong with it. We can't really fix it. We should be able to run this much longer, and then we'll fix it. But what's great is if you say, now that we know, let's shut down on Saturday morning and fix it. Then it'll run for another few years. Or just wait till it breaks, which is what most places still do. We can't afford to shut down. And just to add a little bit more, because today we have so much more wireless technology and smaller sensors and just all the instrumentation industry, where it's come, the valve self-diagnostics. Now you can just look at a control valve, for example. A lot of times it was, I send the signal 0 to 100% to some valve. It does its thing. It's actually a lot of local mechanical pneumatic stuff. You just know what you told it to do. It seems to work. And you wouldn't know unless you went out there and looked at it, that over the last time frame, however long, it was controlling your flow, your pressure, your temperature, whatever the process variable is. But it was slowly controlling it more and more towards one end or the other, open or closed. It thinks it's getting almost closed because the inside is all worn out. The steam or whatever, the pressure drop, it's cut grooves. There's no valves, plug and seat left. There's nothing there. Or there's a bunch of trash in the line, and it's slowly controlling more and more open, but it's actually plugged up with other junk. Well, now you can have that in your DCS or your PLC or your offsite. I think we'll get into a little bit of that. There's so many options now, but wherever your data is being looked at, whatever's analyzing it, AI, a person, or built into the control system, it can trim and it can see, look, hey, the process variable is under control. Things are running great, but we still have a problem heading our way. So let's plan on fixing it before it hits and we're down.
And of course, that makes a lot of sense. And yeah, I think we all know that it can be hard to schedule in those times to fix things because you don't really want to take a running system offline because a running system is a money making system, right? But to your point, like when you really look at it, and I know this is not a new conversation, it's been talked about for a long time, but I do believe in the day, particularly like you said, with the amount of information that could be obtained from these systems, you can use it to not only help this individual system, but you could probably even make it a little bit more macro and look at, hey, well, what is the effect on the yield out of this machine? What is the power usage? And maybe that plays into some sustainability goals that you have, and on and on and on and on. Like you can take this ball of information and you can have it roll out. Now, is that something people do in a first step? Probably not. And I would say just no, they don't, right? You would agree. Yeah. That's like, okay, I get it. I can be very technology driven. Personally, I look at a lot of the CEO reports and look at where people want to go and what people want to do. But that's not necessarily what's happening on the day to day on the factory floor or in the plant and where the rubber meets the road. Hopefully, it's getting there and it is moving forward. But there's a reality of the situation.
Along those lines, there's
Yep.
some the newer facilities. They're starting out. They have their sustainability goals. And they have their power monitors and their current monitors. They don't know what to do. Yeah, that goes back to the data. They have too much. They don't have an expertise in that field. They don't really know what associates with it. Oh, here's our energy usage. Here's our production. But
What do we do now?
how do we tie it together? And then the similar thing with older factories that they have all these machines and they say, okay, we want to get a historian and gather all the data so we can analyze it. And they want all the data. But all these little things here you don't need. You especially don't need it recording every second or even faster. Now you have hard drives, you're just filling up with useless data. I hate to call data useless. It's useful to someone, but get it to the right person.
So I believe, and we could always get into a philosophical conversation about this, but I think all data could be useful. But the question is it valid? And does it have context, right?
Yeah.
And if it has those two things, it may not be valuable today, but if the data is then turned into information, it can be useful tomorrow. And an example of kind of some of maybe to prove your point of extra data that doesn't go anywhere is so I have a house here. It's an older home that I bought. It's been renovated, but it has the original air conditioner. I think it's from the early 90s. It's old. And my power bill was very high. Now, like you, Scott, I have a big family, so it's okay. I got lots of things going on. And I said, I wonder why it's so high. So what does an engineer like myself do? You monitor the power. Not only monitor the power, I monitored the power on like every branch that I had in my electrical panel because just knowing how much energy I'm using wasn't enough. And you know what I found out? The air conditioner uses a lot of electricity.
Yeah.
And so a couple different options. I could change the thermostat and have an impact to pay a lower bill, or I could replace the electrical or replace the AC. The end result is I have a higher electrical bill. So, nothing really changed in the end. So
you changed the AC and got a higher bill?
No. I looked at the price of the new AC and I said, maybe I don't need to change it yet. So I still have the old AC. So yes, I could change it out, and I guarantee you I'll get lower electrical bill, and I probably will do that at some point in time.
You didn't adjust the thermostat.
And I did not adjust the thermostat.
See, I would have changed it 1 or 2 degrees.
Yeah.
And nowadays, one of the first things I did in our home here is I went in and put the smart thermostats and I made the schedules. And another thing that's, you get the cell phone and say, okay, I'm going to, the children, no one's upstairs, we'll change that.
Turn it up. Yep. Yeah. So, well, looking at this, you mentioned the data and you mentioned about the bearings, and you gave some examples of like adding these minuscule amounts of things to help the machine or system potentially perform better, like the rotating equipment. And I'm sure you could extrapolate it out to many different things. To me, and you said people don't necessarily know what to do with the data. To me, the people that would be most knowledgeable about how that equipment's working is the specialist with that equipment. And I know in a lot of cases, those people don't necessarily work in the facility where the equipment is. They're going to work at the manufacturer of the rotary, or they're going to be, the drives guy or the compressor guy or whatever else, the specialist in that area. Are you seeing that as a trend? Is that something that fits into this?
For sure. That is something that's been, again, in the more recent years, very popular. The cloud-based services, and there's another term like something as a service, or maintenance, and that's always been a type of thing. Like you buy a specific, equipment, it's a specialized thing, and you have a maintenance contract. It's similar to, let's say, you rent an air compressor. Well, the guy from that company, he's their maintenance technician. He's going to come in once a month or whatever and check all the stuff and write down everything. And you're already paying that for as long as you rent it. Well, nowadays, you can lease cars from Toyota or whoever, and you take it to them. You're not even having to pay for the stuff they do. It's part of the lease agreement. And now some old school companies were, we buy stuff. We want the ladder logic. We want everything. It's ours. We're not having any agreements. And I can respect that. I like to own stuff. I can mess with it. I can make changes. That's understandable, especially if, we have a secret patent that no one can know about, so we have to tweak all this stuff. But there's pros and cons to both worlds. If you are the owner and it has special equipment, you pay millions of dollars for this, well, now you need to keep it running. Or you got, Joe Blow, he used to be, a good car mechanic. He's our mechanical technician, and he's great at it. Or you got your electrical technician. He used to drive dump trucks before he came here, but he can do pretty good with a voltmeter. And now you got this very sophisticated computer-based thing. They don't know how to work on it. Send them to training, keep it in-house, or work with the manufacturer. Let them send their guys in, or at least plug it into the internet and let them monitor the data remotely. And they can call you, hey, we need to send a guy out to work on this. We've noticed something, and you never would have noticed. And it's not like, you're dumb. You're not a specialist on that piece of equipment.
And there's going to be nuances there, I'm assuming, that, like you just said, you may never consider at all. So it really is an interesting topic. The idea of specialists supporting and maintaining the equipment ongoing. And again, it's not necessarily brand new. Integrators have been doing this forever through maintenance packages and these kind of things. But the idea of collecting the data to send that data out so it can be analyzed and get very narrow on a particular piece of equipment, I think there's a lot of value there. And then it can phone you up and go, hey, I'm going to go bad, or I need this. Somebody needs to come out and take a look at me because I can be doing better than I'm doing today. Call that guy, or the guy will call you and be like, your machine just called me. And you bring up an interesting thing about you said the old school, but it was the term, but there is a mentality, and I do feel like there's a shift in the market of this idea of owning equipment versus leasing or using or paying per use type of equipment. Equipment as a service, I know, is a somewhat of a buzz term or a buzz topic, and there you can pay to, like, just for time using an equipment. You could literally pay for just the use of the product. So maybe you have a multi-million-dollar machine and you only pay every time it produces. There's advantages and disadvantages to both parties, the OEM as well as the user in that case. The most important thing, though, is it gets into a financial dilemma, because you go from really being primarily driven as a CapEx organization to being an OpEx organization. And that and then the insurances and those types of things that come along with those types of things, they become a little bit more confusing. But it is an interesting era that we're in.
Your accountant can take care of that stuff. Yeah,
Exactly. Maybe
a lot of stuff. Yeah.
Yeah, I would love to dig into that topic. If anybody listening to this is in the accounting space and would like to dig into some more detail there. So, this is all well and good. So we have reactive, put out fires. We have preventative, which is change the oil, make sure things don't break the best that you can. There's the predictive, where you're looking at data. Hopefully it's valid data in some structured way, so you can make assessments to improve the system operations. You can have the predictive with specialization, where you're giving that data up to somebody else. They can look at it that maybe is more knowledgeable on the topic than you, that can help you make your system perform better. But we're in an era where data is king. We're in an era that there's all kinds of AI happening. I know NVIDIA just did their earnings and things are going great, unicorns and rainbows and everything is wonderful.
Yeah.
Is there any way that these things can become just maybe a little bit more self-aware and even help themselves?
The next phase after predictive maintenance, like I said, that's actually about 80 years old. And we're still, a vast majority of companies are not taking advantage of what's already here. But I think I have not personally worked with a company yet that's doing this, but prescriptive maintenance is the next step. And I'm sure companies like Tesla are there. Actually, I think Amazon might be doing that too. I've done some commissioning for them, but not just the commissionings. I don't really know how their ongoing maintenance, but their data, their ERP and everything was set up to, I'm sure they were doing it also. But yeah, the prescriptive is, it can still have, trying to think, actually, I think it would be no human involvement. In the early stages, we're still people analyzing the data. But no, now, I don't know if AI is the right term, but just the computer system, it analyzes the data. It writes the work orders. So if you have SAP, Maximo, some type of CMMS, if what tells your maintenance department to go check something, it will spit out the work orders. Go back to if you get yourself a new HVAC unit for your house, just the way they make them today, I would not be surprised if 6 months later, your doorbell rings and you open it and it's some HVAC guy. You're like, what's going on? I mean, he's going to say, your air conditioner said I need to clean the coils or change the filter or something. And you wouldn't have even known. You'd probably get a text message or an email before he knocked on your door. But I'm just saying, it's the equipment will call for help to the proper person, if that's your maintenance team or an outside vendor manufacturer, and you'll get a notification that it's doing this stuff.
So I think I saw that movie. It involves Skynet. So no, maybe not.
I don't know, and I've heard a little talk, but I don't have any idea where is the equipment fixing the equipment. The prescriptive maintenance is the equipment calling humans for help. The line is drawn at a work order has been written for a person to come check it or fix it. Now, what you're mentioning would be some other equipment comes out and fixes the equipment. That'll be a scary day. Yes.
Well, it is. I mean, it seems like a very logical step, right? And with the equipment reaching out, saying, "Hey, this is what's going on," writing the work orders and these kind of things. And I have heard of that type of thing happening, and it probably doesn't directly apply to this, but to provide an analogy, I do think of Tesla, and not necessarily in their manufacturing space, although I'm sure it's probably utilized there as well, but just in their vehicles, right? Yeah. So they have a vehicle sitting in your garage, it's being charged, everything's going great. And all of a sudden, there's a problem. And the problem is that there's something wrong with the software, there's some bug, whatever else. And periodically, that machine, the car, that is a very important machine because it carries very important and safe cargo, which is you and your family, um, needs to reach out to the internet, very scary place, do it in a secure way to download a software update or whatever else. And it effectively gets that with your interaction of saying, yep, go ahead and update. And you now have received a new software system on your Tesla, so it can work better in the future. And that's a lot of risk when you really think about it. Like it's a vehicle, it's far away, it's over wireless, it's over the internet, it's again has to be a super safe system. Yet this happens daily, weekly, monthly, yearly, whatever it is, that these updates happen, and it's operational. Yet when you look at the manufacturing space, and for very good reason, there's a lot of resistance to a lot of this stuff because nobody wants to hook up a control system to the internet, and I think those walls are breaking down. But there's this divide between IT, OT. I know that's getting better, and that's a whole nother episode. These kind of things. But this data, the information, these updates, the ability for a machine system or process to reach out to say, "Hey, I need help," and be able to get that help effectively, I think is a really important way for things to move forward. Just in general, because expertise is exactly that, expertise. And the more granular and fine-tuned and focused you can get, better things will perform in the future.
You talk about the machine reaching out to the internet. Yeah, it's one thing if, let's say, you have a cryogenic plant where you're actually making $1 million a day. You have a bunch of valves and transfers. It's a continuous process doing the same thing. You might have a gas chromatograph there. It's the only different piece of OEM equipment. Like the rest of it is just all basically a bunch of the same stuff. And so you train your maintenance people on that. And you might actually do that pay as a service or specialty type things with the chromatograph company. And that's the only other company. And use some service that actually comes out to monitor all vibration, but they still do a bunch of the same thing. We got a bunch of temperature and vibration sensors. It's as big as that facility can be. It's a repetitive. But now you got a textile manufacturer, and they have a 100,000 square foot warehouse, but there's over a dozen machines in there, and each machine has there's something that's doing this little piece, something that's doing this little piece. And we're having to basically, it's like a giant glue gun to glue two fabrics together. Now we have to know how thick it is, and to do the fastest way to actually use a radioactive source. It's cesium, I can't remember which one. Here, it's a beta particle emitter. And but each one of those machines are totally different. And you got the hot oil calendars. Well, this technology goes back decades and decades. And so it didn't used to be there. But when they first started saying, oh, hey, this company wants to have access to their PLC. Well, there's been times in the past where they made an update and it was in the middle of production. And although that was 20 years ago, 30 years ago, no one's forgotten it at that facility. They still remember. And like I said, you have a dozen different OEMs and they all want connection. And that gives you a dozen different places for actual security, vulnerability, and things. And you're right, the walls are breaking down. We are heading that way. But the resistance is there for a reason. I mean, some are just crazy conspiracy theorists, but a lot of them are, oh, we tried that. It failed.
Yeah, no, I truly, I mean, you've lived it on the factory floor. You've lived it in these facilities, right? But I understand it, right? And it is a different world, Oh, emails aren't going through. Reboot the server. That's a little different than we got how many gallons of crude running down this pipe, and we can't just shut off that valve, or we might have a big explosion because it's a continuous process, right?
And don't reboot the server.
Don't reboot the server. Yeah, you can't do it. So it's just different. It doesn't mean we stick our head in the sand and sing la 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 and pretend things aren't there. We need to figure out a way to move forward. How can we do it effectively and safely? So, and it's all along the way here. So this is all really good stuff, Scott. Is there anything else that you want to add on this idea of maintenance going through from the reactive to preventative, predictive, and now even prescriptive? It's definitely a very forward look, and I love the idea. I love the thought. I love the idea of machines creating their own work orders and things, sending it out, making that a less manual process, making sure the things get done. I also think there's an opportunity to tie things in, and I think truly leverage AI maybe in a micro space on information learned only in those particular environments. It's definitely a little outside of the scope here, but I think there's a lot of value there to be able to leverage those LLMs, not from an internet perspective, but just on there in that micro machine. Is there anything else you wanted to add?
I think companies just need to focus more on maintenance. And again, in this conversation, I don't know who might watch it that it would actually lead to a difference. But a lot of companies, it's all about their strategic production goals. Maintenance is just kind of a necessary evil they have to deal with. They don't put enough time and effort into it. Hopefully, some of the predictive maintenance will help with that. The historical, always reactive, firefighting, fixing broken stuff. They don't have enough people, so they fall behind on the preventative. I just have the maintenance background, and it seems like every industry, they don't plan well. They don't have enough maintenance. We need to increase production. Well, you can't. Your machines are broken. You need to fix them. And don't fix them cheaply and quickly. Actually, put the time and planning into fixing them even better. So, and then you get in the whole reliability, which years ago, reliability was just part of the maintenance department, but now it's kind of a separate thing, which is trying to do more predictive maintenance. It's not a bad thing. So hopefully things are trending that way.
Yeah, good. Well, thank you for those added comments there. So, Scott, I want to thank you for being part of the podcast here today and giving us the knowledge and really some of the details and some of your view on this maintenance world and drawing on your 30 years of experience. If somebody listening to this wants to get in contact with you, how do they do that? And is there anything that you wanted to talk about from your side, from a personal standpoint?
Well, HighlanderControls.com is my website, and I actually started my company a few years ago, but just been doing little contracts here and there. I've been doing electrical work, running cable, running conduit, wiring up panels since the 90s. And we talked a little bit earlier. Yeah, I was a teenager. I wasn't two. But then I got into industrial electrical in the 2003 or 4, maybe, get nuclear plants, and then oil and gas. Got into automation, instrumentation, and now I even do energy management, so sustainability goals, environmental. So check out the website, send me an email, and still a one-man band. It's hard. I made the website real fancy. It looks like, but I actually do have lots of other guys I work with. So
reach out to you on Highlander Controls. Highlander Controls would be the place to find you then in the information?
Yeah, and LinkedIn. I probably waste too much time on LinkedIn also.
Okay, good. So LinkedIn and Highlander Controls, if you want to talk or communicate with Scott about maintenance or other electrical needs, it sounds like, and he's got you covered.
Thank you, Ira. I enjoyed it.
All right. With that, thank you guys very much, and I wish you guys all a great day. Have a good one. Thanks a lot for your time, Scott. Bye.